What's up, Kybon? Morning, Jake. Morning, Janessa.
Morning.
Morning, Lauren. Morning, Stud.
Good morning.
Right on. Luke. Good morning. Josh.
Oh my God.
What's up, dude?
Morning, sir.
Fantastic. Andrew. Morning. Darren. Morning, sir. Good. You all right, Kybon? Oh, yeah. It's bringing back memories, that's all. Just remembering where I found some of this stuff. It's pretty awesome. That's hard.
My mom made it. She put like gallons of sugar in it. Yeah.
I used to make little block of sugar at the bottom before you mix it in.
Liquid diabetes.
Morning, Jacob.
You know, sometimes
Just talking degradation.
We're getting into that. Yep. We can't. Rub it on the tree. Yeah, but degradation is not glazing. Let's see. And did you get one?
Yeah, I just passed.
Okay.
Holding on to it.
I just pass it around, hold on to them. There, you get the pink one. Yeah.
really gets between the teeth.
Yeah.
All right. Good morning, everybody. Happy Tuesday. Hump day. All right. This morning, we'll do a little bit of recap. I think we could do some recap because some of the Canyon City boys are here. And then obviously Mr. Jacob is new to the super school. So obviously I'll start with some questions. What is the melting point of aramid fibers?
A lot. With like 500.
Sounds right.
Like 500.
You're close. You're close. You're close.
Yeah, here's 675.
What about HMPE? Now you're just guessing, Ken. Okay, I'm just kidding. I'm not gonna start off with that. Okay. If I asked, I want a unbalanced rope, Mr. Brian. If I want an unbalanced rope, which rope would you grab? You don't know. You're fired. Jaron, 3-strand. Very good, sir. Very good. Why is it unbalanced? Janessa.
The ways in which it's woven together, if it's under load, it's going to twist. Is that it?
You're close. You're close. Yep. It is a way, but there's a key reason why there's behind. Okay, yes?
They're all woven in the same direction.
Same direction, right? All the fibers are going in the same direction. So when it's loaded, right, it wants to unravel. One of the downfalls of 3-strand, right? Remember, if I want to be climbing on it, I'm going to be doing a lot of this. Yes, sir, Michelle.
What's like the upside of like? Why do they make that? Like,
All right. Okay, it's cheap. What else? Cheap. Nubs. Good job, Dan the man. You get a gold star. Yep, the surface area. So the surface got bigger nubs, we call them, right? The lays are bigger, so the impact, or the surface that this rubs up on the tree, right, is minimal compared to a smaller braided, like a 32 or 24, right? Cool. I'm gonna say yes, because I've never seen like a 7 or a 9 or an 11, but that doesn't mean that there's not a different odd number woven strand of rope. Good question though. So you could make, maybe not. Let me take that back. Yes, to a point. So what you could twist the strands different directions. You wouldn't have like a 100% equal rope, right? Because you could twist one's right hand turns and then the other ones would be left hand turns, but you still have the twisted braid. But you could do like, you could weave 5 together and do 3 one way and 2 the other and twist them, and you would have a more balanced rope, but you're still going to have that unequal. There's going to be more left hand than right hand per se as far as the twisting goes on it. Good question. Good question. Okay. 16 strand. Do they have a core? 1.
yes.
Yes. All of them. No. But yes. Is the core part of the strength? It depends. No, it doesn't depend. It is or it isn't. Okay. Right? Does the 16 strand, does the core play a part as far as its tensile strength? Say yeah. Yeah, yeah. No. No, it doesn't. No. What is the purpose if a 16 strand has a core? What is the purpose of the core, Mr. Andrew? So this is what we're talking about.
If it has a core that it's not dependent on the weight.
The 16 strand has a core that's not dependent on it. Andrew?
Structure.
Okay, structure, right? So we want to keep it more round under load. Okay, so if I pull the core out, it's going to be soft and supple, a little more user-friendly, not ability, but it's going to flatten out when it goes over a sheave on a pulley or flattens out when I run it through my zigzag or something like that, right? Okay, so remember we talked about different ways that they construct their ropes to perform a specific task, right? Cool. This is all gonna play a part in our inspections. We need to know this stuff, okay? Okay, cool. Class 1, Class 2 types of ropes on double braids. Luke, do you remember? Yeah, you weren't here. Mr. Darren?
Not too sure, no.
Not too sure? Okay, Class 1, Class 2. What's the difference?
Strength?
Okay, strength, yeah. Janessa?
Core dependency.
Core dependency. Good job, both of you. Gold stars. 2 high fives. Right? Okay, Class 1. Well, which one's which? Class 1 or Class 2 is the core dependent? You say 2? Who says 2?
What was the question?
Is it Class 1 or Class 2 that's core dependent? All right, Class 1. Or almost half and half. Some of you guys didn't raise your hand because you don't know, huh? It's going to be out. Let's try it again. Class 2. Oh, there's more of you. You're multiplying. Class 1. Okay, it's Class 2. All right, so Class 1, just remember, the bigger the number, the stronger the rope gets. 2 is bigger than 1. That's how I remember it, right? So 2 is going to be a core dependent. It's going to be that, right? As far as I know, 2. Yep. Cool.
A cruise ship rope, too?
Yes. Yeah, because it's the same. So the high molecular polyethylenes, the HMPEs, and the aramids, it's still the same fiber. It's just you have more of it, right? They make them like 3 inches and 4 inches and these monstrosity things, right? So that's why it can hold those ships down. Cool. Okay. So with the Class 1, Class 2, what are some key performance characteristics between the two that are different? Remember the characteristics?
Maybe like a visual trick?
No, because remember I said you can, unless it's in crane rigging, in our world, the colors aren't standardized. Like yellow is not more strong than red, but in rigging, red is more strong than yellow.
Even though like the Class 2 is going to have the 2 little like stitch marks on it. You know what I mean?
Stitch marks.
Like the little, like the, it's like a colored piece of thread in there. Like you had the cranes things the other day. Everyone was Class 2. Yeah, like they had that like piece of stitching in it that helped identify it was Class 2. Would that be something? Or no?
I don't remember there being stitching. I remember there's a lock stitch.
Maybe that was it.
Is that what you're thinking of for the splice?
Yeah, maybe that was it.
Okay. Yeah, so the splice lock stitch is not a key identifier, right? It's not an identifier. No. Okay. Yeah, very good, Lauren, right? Which one has a higher load capacity? Class 2s, right? Class 2s are going to have higher load capacities. All right, so then we talked about, so why not just use Class 2s? So what's another characteristic between the two that differentiates it? Elasticity, okay, right? So the reason why we use Class 1s over Class 2, there's multiple reasons, but one of them is its elasticity, right? So the ability to have shock absorption, right? Remember about the truck? Instead of it just peak loading straight into the wall, right? It applies its brakes, slows it down before it hits the wall. We have less of an impact. That's the difference between a Class 1 and Class 2, right? So Class 2s, it's super strong, very, very little elasticity, okay, right? It was like 4%, 1.7% is its elasticity, where the Class 1s, right, are nylons and polyesters, 15 to 28% elasticity under load, right? So there's a safety factor incorporated into those ropes, right? Okay. What other characteristics, right? Why do Class 2s have covers? UV degradation. Okay, so Class 2s have they hate the UV, the UV, coffee's kicking in, right? All right, then. What we're going to talk about is these class 2 ropes. But no, so they immediately, once they hit the sunlight, right, they start to degrade. In about 6 months or a full California summer, your class 2 rope is going to be useless because of the degradation behind it. There is a formula for how quickly. I don't have that. I'm sure Google can figure that out, but you start to lose degradation. Okay. One thing that we didn't talk about is that degradation. So I think we touched it a little bit last time, right? So remember the chart of the melting point? So we had degradation point and then the melting point. Okay, so the degradation point was smaller than the melting point, obviously. So there is a point on the ropes where you heat it up so much that it starts to lose its ability and its strength, and that's its degradation point. Okay, remember that because that's important. Because I got some cool examples here when we do inspections. Okay, okay. Let's see. What other questions can we ask? Okay, kern mantle, a kern mantle rope. What's the difference between a 24 strand kern mantle and a 24 strand double braid? Miss Linda?
The core construction and the double braid, the inner core is woven braided, and then on unmantled they're twisted in opposite directions.
Yeah,
Parallel.
and parallel. Right, perfect. Very good. Very good. Okay, so if you guys double braid, right? The one you guys pulled out my core, that's double braid. Yeah, you guys. Those are the guys, not the girls. I know they wouldn't do that. Okay, so 24 strand double braid, braided cover, braided core. Okay, these are braided. Kern mantle, braided cover, parallel fibers in the core. Okay, and then to keep the balance feature, right? So you're gonna have, oh, it was me. My rope samples are falling apart. Right, so we're gonna have half are gonna have right hand twist and half are gonna have left hand twist, right? If they were all right hand twist, if it were to be on a load, right, that core would want to start to unravel itself. Okay, that's where we keep the core, the ropes balanced. Okay, what device can I use and not use? Wait, no, what device can I use on a kern mantle that I shouldn't use on a double braid? That was a better question. It was. We're not going there. Yes, hand ascenders is what Linda was saying. Hand ascenders. I'm sorry. Well, you're not in the video, so. Oh, but yeah, it was me. Yeah, hand ascenders. Yeah. HR. All right, yep. So hand ascenders. Now, what about those hand ascenders? So two things playing the part, right? So there's micro grabs, there's hand ascenders, there's foot ascenders. What's the difference between them that I should use, I shall use on a kern mantle and shall not use on a double braid? You guys remember? Okay, micro ascenders and hand ascenders both all have camming devices, but you're narrowing in on it. No, not radiated capacity. That's a good guess though. Ken?
It's the teeth and the hand ascender.
Okay.
Kern mantle, because they aren't braided as the teeth go through it. It's not basically like if you were to fall on it, separate the braids out, whereas because they're straight, it'll just go straight to the shop.
Correct. Okay, perfect. Yep. So tooth cammed hand ascenders or camming devices, right? Kern mantle only. Now, can I use a hand ascender on a double braid? Just not as life support. Good job, Dan. Okay. The second you use that hand ascender, obviously you got to make sure it's rated. Okay. Or any tooth cam device and it's incorporated into our life support system, it has to be able to withstand a fall, and therefore we need to use a kern mantle rope, not a double braid rope. Outside of that, it does not matter. I can use a hand ascender all day long, a foot ascender on double braid, because if I fall, I can let go of that and it's not holding my life, right? I'm not tied to it, and that's my point of arrest. Okay, cool, very good, very good, very good. What type of construction are our slings usually made out of? Jarrett, do you know? Mr. Jacob? Nylon? No. Construction.
Double braid.
Not double braid. Okay, some are dead-eye slings. Well, okay. Whoopie slings, loopy slings, ultra slings. There we go. We'll be more specific. Okay. What are those usually? What construction are they usually made out of? 12-strand hollow braid. Good job, Linda. Yep, 12-strand hollow braid. Okay, that's this right here. Strong. Well, it's the same as polyester. Yeah, but it's polyester is usually what it's made out of, not nylon. Okay, cool. Give me some different types of splices. Go ahead, Jacob. Nope, you're wrong. What about you, Jaron? You got one? Different types. Okay, eye splice. Okay, what kind of eye splice? Okay, yeah. Okay, dead eye. Okay, that's a type of splice. Yeah. All right, Andrew. I know you've been itching because you locked Brummel. Very good, very good. Okay, and then there's one more. You have to have a machine. Sonai. Okay, Sonai. Okay, very good. How much capacity do the eye splices usually retain on your lines? Okay, I hear 90 to 100, 100%, 60. What do we think? Yep. So the strength tensile retention of an eye splice retains usually how much? Okay. Cool. Yep. Usually 100%. Usually 90 to 100% of it. Okay. What about a bowline? If I tie a bowline into my 60%, okay, so I have 60% of that strength. So if my rope's rated for 10,000 pounds, what is it actually rated for when I put that bowline into it? No, you're the other way. Okay, 6,000 pounds. Okay, so even on a brand new rope, the second I put a knot into it, I am reducing its tensile strength by up to 60%. Bowlines are 60% reduction. Okay, so when I calculate that into my rigging plan, I need to calculate that knot into it because my rope might say 10,000, but the second I tie that knot into it, right, I am reducing the capacity of that rope. Yeah, Luke? They do, and I have no idea why. I think it's because you're pulling on two legs. It's the same thing with the knot. I don't know why it does that. I should probably figure that out. But eye splices do. I don't know if it's just because there's a lot of bends in it and the way it cinches down and it tightens up on itself, which probably is one of the factors of it cinching down and the bend ratios in there causing that. But I don't know. I've thought about it because, right, in eye splice, if I'm going over a piece of hardware, right, the bend ratio is the same whether I put a knot on it or not. But if you think about it, if I do a straight bowline to like the pin on a block, it doesn't break at the loop in the block. It breaks at the knot. Okay, so it's bending, and then I think the cinching is involved. Is probably why.
If you're like rigging something, so you're running bowling, like you had that half hitch, what does that do to that equation?
So if you add the half hitch in front of it, you're gonna reduce the load on the bowline. It's still a knot, so you still have a reduction. I don't know what a half-hitch reduction would be, but it's still going to be less than a ice splice would be. Yeah, for sure. Cool. So ice splice strong, not weak. Yoshida. Happy birthday. Happy birthday. Happy birthday. Okay. 12 strand. Okay. So I passed around some devices. Yep, hang on to them. Who found bad things in them? Okay, what'd you find in yours?
Oh, I don't have it anymore, but there's green friction saver.
Okay.
Is the actual rope is like basically burned and degraded enough that 10% of the wear is cut.
Okay, so you found that it's burned. Okay, and that's it. That's just been burned.
Well, that it's been glazed on the burn as well, and then the actual metal ring itself has some signs of some burning on it.
Oh, you're talking about the hardware here?
Yeah, and just all I noticed was burning, but yes.
Okay.
And then right by your right.
Yeah. All right. Yeah, this was a cool one. So out in Cali, just doing my thing. This guy had, what's the white tape that no, not masking tape. Athletic tape. Thank you. Yes, athletic tape wrapped around this, and he was still climbing on it. There was one of those ringed Luke Prussick's was on it as well. He was climbing on it. I was like, let me see this. Let me see this. The dude was climbing on this. He just thought since he wrapped it and covered it, out of sight, out of mind, so he was safe. So it was super cool. I gave him a new one and told him not to do that anymore. But yeah, this one was interesting. So obviously, okay, it's been nicked, more than likely by a handsaw or a chainsaw. That's what that looks like. Core shot, which means the core is exposed. Okay, definitely. Anytime the core is exposed on your rope, it's out of service, 100%. Okay, so that's one. Okay, we're gonna go through a bunch of criteria. Okay, so remember that core shot, core is exposed, that rope's done. Doesn't matter if it's right at the eye splice in the middle of the rope. We're gonna cut it. We're gonna remove that defective piece. And now we have some tag lines or smaller climbing lines. Okay, that's a no-go. All right, so that's a no-go. Now that was a good. I didn't even think to bring that up, but yeah. So what he's seeing here is this is just rust, and from where? It's not burnt. Yep. Yeah, it's a good thought, right? So it looks like someone took a lighter to it, maybe. I would hope they wouldn't do that on a life support, but hey, people do weird things like put athletic tape to cover up defects. But that's just wear in the metal elements attaching to it and it causing stuff that science people could figure out that I can't. So, okay, cool. All right, who else found stuff? I gave you guys some tricky ones. Yes, Linda, what'd you find? Okay. Glazing. Oh, and we have flatness. Okay, very good. Very good. Okay, so what she found, she's saying is glazing. I gotta sneeze, hold on. Purple elephant. Come on. You're not helping.
That's the point. It's supposed to prevent you.
It worked. All right. Dragon fruit. Okay. All right. So, okay, this is a Prussick ring. Okay, an eye with that's just been sewn. So we have a sewn eye splice onto it, onto a ring. Okay. Usually these are used for on your cambium savers. I mean, you could put it on your lanyard as another attachment point for life support or redirects. But what she's found is not glazing. It's actually sap. Right? So that's a big thing. This is a good one that usually most people are like, oh yeah, it's definitely glazing. So now I know the application of this because this was mine. And so I know what it's been through. The first guess is like automatically go to the worst when you're inspecting. Don't be like, well, like it's rope, it's cheap, we will replace it. Your life is more important than a $20 piece of equipment, right? Who here thinks they're less valuable than a $20 piece of equipment? Go away, Jeff. No, right? $20. Well, actually, they're probably like 25 now. Okay, so $25. Even if it was $100, your guys' lives is worth more than that. So if there is a defect and you have questions, obviously ask. Get rid of it. Right? It is replaceable. You guys are not replaceable. Okay. Cool. So it's actually SAP. Came off my friction saver, but it looks like glazing, right? So if I know the hardware and the device and what it's used for, the likelihood of glazing, especially if I did take a fall in a friction saver, which was, you were spot on. Like, how did that glaze get there? Okay, you must have taken a fall that cinched down onto it. I did not fall onto it. Like I said, it's just sap. So that's key part of your inspection. Okay, so kind of know the equipment, what it's been through, and then think about what has caused this, basically. Okay, that makes sense. Yeah. Okay. All right. So that's sap. The flatness in this is just the cover is real loose. Okay. So when they sew these together, they don't milk the ropes out. So there's going to be some suppleness to this, right? Because we want it supple so we can actually tie it around things and cinch it up. So you're really looking for that inconsistency in the core, which she talked about in those flat spots. So I have one out there that has a core defect in it. And we can play around with the differences in it. So, okay. So that's sap. And I'm going to help you guys when we get into glazing, differentiate between the two. Okay. Okay. Who else? Alan, you were raising yours. What do you got?
Yeah, this one's. Is that blue? Oh, okay. The ice plate's coming back in while it's standing in the middle.
Okay. Yeah. Very good. Very good.
One that had the core defect though too.
Yeah.
Yeah, it's this ice place. There's one that's like you go through it and it's just super hard, different than the rest of the road.
Okay. All right. We'll go to this one, then we'll go to yours. Okay. All right. So one thing I want to point out that Al was doing, and this is not to pick on you, okay, is when he's inspecting, he's going like this. Okay. Opening it up and flattening out is not going to help you with your inspection. Okay. So when you do rope inspection, we're going to grab and slide through. You've got the manliest hands there was in life. You've got like 80 years of tree work. They're basically giant calluses. We can run 600 feet through your hands and you wouldn't even feel it. Okay. All right. So when inspecting like your ropes, especially for core defects, right? We're not pressing, right? Because pressing is not going to give you anything. You can really feel the diameter inconsistencies when we're milking it or when we're pulling it through like this, okay? All right. So you nailed something I want to point out, right? So you're like, oh, there's a flat spot and there's bumps and there's stuff going on there, which you can feel in that, right? Who wants to feel that? All right, we'll go you first and then pass around, okay? So there is definitely a core diameter difference in that eye splice, or I mean in that eye and eye, okay? But now that you know there's different types of eye splices, how they're made, right? Now he's like, oh, it's a taper and then it gets smaller. That's an eye splice. Now you can differentiate between the two because you know what's going on the inside of that, okay? And that one right there is the B line. And what they did, instead of it sewn, right? Instead of them taking it and sewing it together like this, they took the core, did a locked Brummel, and then they have the sheath and then they whipped it off to the side, okay?
And they're equal.
And they're equal, okay? Right, so knowing the construction, the type of rope, what it's used for, what's going to help you guys when you do your inspections to better identify if that's a defect or not, okay? Because I've got some in here too that you're like, oh, that's a defect. It's actually not a defect, okay? Cool. Okay, Jacob, you had? Don't burn your fingers. Don't burn your fingers. Okay. Actually, I don't think it's this one. I don't think it's this one. Who's got the other one?
Why is Teddy get two?
Why is Teddy get two? Yeah, let me see that other one. I should really like, no, the other one's a ring. That one. That's the one. That's the one. Yeah. Okay, I did this just to demonstrate a purpose. Okay. All right, so normally what I do is I'll set these on the table, right? And then where's the, there's a third one. Did I have it? I had it, I think. Oh, you had it, okay. Okay, just by looking at it, which one do you think probably needs to be retired? This one, the middle one, or the one at the end? All of them. My far right? Okay, all right, fine, guys. Okay, usually the dirty one, right? Usually the dirty one, the one that looks like it's been abused and used. It's got some sap in it. It's got some phrase in it. Okay. When I put these out on the table and I have people pick out like which one do they think is going to be the one that's retired, it's always the dirty one, which is usually the guess because, right, it's been used, it's been abused, it's probably on a point of retirement, so I'm going to get rid of that one. Right. However, the cleaner one, and I've ran into this before where there's been defects, and so when you're inspecting, especially the sewn side of things, remove or slide off the cover. Okay, two reasons. One is you want to be able to, now if it's sealed like that one, it's going to be difficult because they usually have glue on the shrink tubing. Definitely don't try and rip that off, but peek in there. Okay, so on the eye splices that are sewn, if one strand is cut, okay, it's a no-go. Okay, that one needs to be removed. One strand cut on the sewn eye, it needs to go. Okay. The reason being, right, that's a all the way around thread, so there's a chance of that unwinding and then coming back out. Okay. There's actually two levels of eye splice or stitching that's in there, and then depending on the stitch pattern that they select. So usually there's a smaller one, and then above the one that you see is going to be another one that goes back and forth. Okay. But anytime, so that's criteria number two, right? So first one is core, that's gone. Two is going to be on the sewing. If any strands are cut, that's got to be out of there as well. Okay. But then also on these covers, why it's good to remove them is to inspect the core in there. So this one I did cheat, but there have been cases where manufacturers do have defects. Okay, even if it's brand new, always inspect your equipment. Always, even if it's brand new. We were at a comp in, I think it was like 2012, and this is why I started my, anyway, guy had brand new rope, and he was arguing with me. He was like, yeah, dude, it's brand new. Like, why are you inspecting it? We actually found a defect in that core when we were doing our inspection. The core was actually completely separated. We had to send it off. And that's when a technical notice came out by the manufacturer to recall the certain serial numbers on those ropes, and they had to redo them. So it is possible. Is it rare? 100%, right? We talked about ISO 9000, right? Right, ISO 9000, if you, like Petzl or DMM, those companies, if they have that accreditation, you can trust that they've done their due diligence to make sure that your product is 100% safe. They use those third-party testers to test it within whatever parameters they need to be tested in. And then they get that certification because they passed that, okay? But that does not negate you on your own inspecting your own equipment, especially for life support, okay? But in this one, pull back the sleeve, the core is missing there. I pulled it out, cut it, and then I stuck it back in, okay? Just to prove a point, okay? But it has happened before, okay? So if you can remove covers, remove them, do your inspections. When we're milking, right, we're not squeezing, we're milking it, okay? We're gonna burn our little fingers, okay? All right, any questions on that?
I have a question, but not on that. What about like X-rings, like under the ring? I've been known to heat those up pretty good. Like, there's no way to really inspect under there. Like, when do you know that they're done?
Well, I guess we're gonna go into that one because it's a good question. We'll pass this around. All right, we'll start here and just kind of pass this one around. Take a look at it. So why? Yeah, like in Super School, I like to go in depth in everything because as we start progressing, stuff starts to link together. Don't touch that wheel. Leave it alone. Things start to come together, right? We can start understanding the difference between, hey, why is there a core diameter difference? Oh, it's because it's the tail end, it's the berry of the eye splice. The construction when we're doing our inspection, right? We have a class 2, and my cover is just beat to snot, right? But it doesn't matter because the cover is not holding the strength, it's the core, okay? So knowing that stuff's gonna help us with inspection. The degradation point of material, right? So polyester and nylon, degradation point for that is below 300 degrees, right? That's, what can you bake at 300 degrees?
Lower end, you want to bake like meringue.
Meringue,
Yeah.
okay? Right, you can bake some stuff at that. So our ovens can reach 300 degrees. Rope and friction can reach 300 degrees really, really quickly. Right, really, really quickly. So we can reach degradation points really quickly just by applying friction and not using our equipment in the appropriate way. Okay, and I love this example here. So this one, as you guys pass around, you can see major defect in that. Obviously, the rings have been worn. That's an obvious sign. But if you look below it, you can see the slings are starting to do things. It's starting to melt. So what happened is in California, trees are 200 feet tall. The wood is heavy and it's hot as balls there. Okay, hot. It's freaking. It's stupid. I hate it. Right? You know what I'm talking about. It's miserable. Yeah, I hate it. I hate the heat. Okay, so what we're doing, if we're doing a lot of repetitive motion in the same spot with high loads, it's already 110 degrees. Okay, how quickly do you think I can generate 300 degrees dropping a 500-pound log 150 feet? Within seconds, I can generate degradation point behind that, right? So first off, so that's why we use aluminum rings as opposed to steel. Aluminum does a better job of heat dissipation, and steel does not. It retains its heat really, really well, okay? The other thing is that if you can rotate that, we can kind of disperse the heat within our rings. If we're doing a lot of repetitive motion rotate that around, we're gonna save wear, but also we're moving the heat around and hopefully it's cooling it off, okay?
Rotate it.
Yeah, so you can rotate these rings within the splice, right? You can rotate that, okay? Some guys, I've seen them, we've poured water on them. Our water bottles, we'll just put a little bit of water on that. We'll take a little bit, let them cool down. But that is something you have to think about in your rigging plan and to know. Otherwise, you'll end up with something like this where you get degradation and then actually melting of those slings that'll cause failure from those slings. Right. So at the bottom of the rings, you can see it started to melt and sort of peel out. Rings got so hot that it melted the polyester that's in that Trex line. Okay. So using your rope within its design limitations, right? We talked about Okay. Who had that? Jacob did. That red I and I. Okay, so can I climb on this? You blew a raspberry. Okay. Who else would blow a raspberry at climbing on this? Yeah, you would. Okay, definitely. Okay, this is one of those things that's out there, right? What does this look like? Yeah, it looks like a prussic, an ionite, right? So an uneducated person is going to grab like, this is actually cheap. This is cheaper than your beeline. I don't know. Someone's got the beeline. Okay, so this is cheaper than beeline. So we as arborists, our equipment is expensive. It is stupid expensive. How expensive it is. Okay, so if I'm a climber and I want to be good, or I'm just ignorant, right? I'm like, hey, this is cheaper than the other stuff. I'm going to buy this one, and it comes in yellow or red. I'm going to start climbing on it. Okay, but why can't I climb on this one? What's that? Nope. No, that's a good guess though. Okay, the way of the construction, he said, right?
Because there's no details on it. Like, is there?
Oh, yeah, 3/8 Trex Prussic with eye to eye. Professional use only. I'm a professional, so I can use it. Right? And that's about as far as I usually read. And then now I'm going to go climb on it, right? Okay, what's this made of? Okay, nylon, polyester. Okay, is nylon and polyester really good at heat resistance? Negative. Okay, remember degradation point? Okay, remember the degradation? How quickly, if I use this as an iodine, do you think I can generate 300 degrees? Especially how fast I climb? Be instant.
Melted on the way up.
Right? Melted on the way up, right? Okay, so here's a great example of knowing the piece of equipment, knowing its construction, what it's made of, and its application for that. Okay, so with our ionize, they have polyester nylon in them, correct? But what makes them different? Correct, degradation point, but it's not as part of it. But why? What's in it? What's the difference between this and this one? You guys remember? Angle of the dangle. Okay. Remember what it's made of. It's material. Okay. So we do have polyester in there. The black is polyester, and then you have aramid fibers. Okay. Aramid fibers have a better high heat degradation point and a melting point, like 900 degrees. Okay. So this can withstand that that heat that's generated on the pressure cord. So that's why these are our pressure cords. These are not. Where you'll find these, okay, is going to be on your lanyard, usually on like a 2-to-1 lanyard. Okay, or you're going to use it for, like Miss Linda said, you're going to see them in rigging applications. So you're going to tie this onto your pool line, hook up a 5-to-1 to it, and this is your pressure cord for that. Okay, so application, knowing what they're made for. Cool. You with me, Juan? Oi. Okay, inspection. Okay, so glazing. So usually, I think I passed this around last time, but we'll pass them around again. So this is an example of glazing. So knowing the difference between glazing and if it's just got sap on it is a good way to differentiate between the two. Okay, you're going to feel glazing is melting of the line, so you're going to feel that snake skin. It's going to be gritty and pokey, and it's going to burn your fingers. Okay. Whereas the sap, right? Sap is going to be a little bit gritty, but you're gonna see. Actually, I don't know because it's still going to be kind of flaky. What would be a good way to differentiate between the two? Between sap and glazing.
One's tacky, one's not.
One's tacky, one's not. Yeah, okay.
Glazing, you get a little bit more burnt ends on it, like a little bit more crusty.
It's crustier. I like that. Okay, yeah, that's what I would do too. Yeah, yeah, I like that. It's going to be crustier. Okay. Also knowing what the tree's been through, right? If it's sap, I'm going to know I was just in a ponderosa pine cutting it down. It's definitely sap, right? Definitely going to be sap, for sure. Okay, so on glazing, how do we? Because it's inconsistent. There's not individual strands that are being cut. It's just defects on the rope. Okay, so any kind of defect on the rope is going to degrade it in its tensile strength, correct? Right? Because it's damage. So that's damage to it. So with that damage, we need to have parameters. So the parameter is 10% of the diameter of the rope. If it is glazed, it needs to be removed. Okay? So if I have a 13 millimeter rope, okay, what's 10% of 13 millimeter? 1.3 millimeters. Okay, so if I have 1.3 millimeters of glazing, okay, let's do American, let's do freedom units. Okay, so 13 millimeters, half inch. So 10% of half inch is, I don't know. I was hoping you guys would know. What's 10% of half inch? Well, that's Chat GPT. I don't have my phone on me. All right. So anyway, so 10%. So we'll get into that. Yeah, we'll get into that. There's going to be different stuff. So this is for climbing. Okay. Rigging is going to be a little different. Yeah, we'll get in. There is a difference, but this is for climbing. Okay. Okay, so that's glazing. So 10% of the diameter of the rope, the amount of glazing, okay, is going to be grounds for removal of that line. Okay. Cool. Okay, so glazing. So now, what if we have cut strands? How many strands or how much damage to my rope can I have until that thing's got to be cut, right? If I ran my gaffs through my climbing line, okay, what'll dictate me? I've done it before, so it's okay. Yeah, I've done it a lot of times actually. Like brand new rope. Usually, brand new rope is when you do it. Yeah, right. You run your gaffs through your climbing line. You're Linda, and you're just nailing this crab apple, and you whack your climbing line, right? How many strands? How much damage can my rope take until my rope needs to be retired? Okay, one strand. What if I have a 32 strand rope? So I have 31 left. That seems pretty safe, right? Right? That was a good guess, though. Okay, so 10% of the strand count. So see that we got a 10%, 10%, 10%. Okay, so working loads 10%. Okay, so 10% for climbing our life support system is 10%. Okay, all right. So if I have a 24 strand double braid class 1 and I have 3 strands cut, can I still climb on that line? Negative. Okay, what if on my climbing line I have 1 strand cut at my eye splice, and then 20 feet down I have another strand cut, and then 20 feet down I have another strand cut? That's 3. So I got to get rid of that rope? Nope. No, I don't. Okay. So
Same strand.
It wouldn't matter. No, I'll explain why here in a second. Okay. So 10% of complete cut strands within 6 inches of rope. Okay. So within 6 inches of your rope, if there is 10% of the strand count cut within that, that rope's got to come out. Okay. Why that 10%? Why isn't it, or sorry, why is it that 6 inches? Okay. So the rope is woven, right? And usually it's woven together. Remember the Chinese finger trap thing we talked about with the eye splice and the berry? So that friction that's in there, you can have those individual strands and it's still going to be okay. Obviously, I'm going to reduce if it's a ring line, like I'm going to reduce that. It's still going to hold together, even if it's the same strand. Okay, it's really weird, but that's how that that plays a part. Okay, so what is, if I got cut strands, what is it? Jarrett. Okay, I'm inspecting my rope. What is the requirement for removal of cut strands? Okay, I'm on a 16 strand. Okay, so what would it be if it's a 16 strand rope? 1.6 strands cut within 6 inches. Okay, see how that works? Okay, so glazing, right? I have the snake skin, 10% of the diameter, 10% of the strand count within 6 inches of lay. Okay, that's for fall arrest. We'll touch a little bit of rigging. So rigging is going to be 5%. So life support usually has a 10% working load limit, and that is basically life support's going to be 10%. Rigging is going to be 5. Okay, so 5%. I think I have it backwards. It's 5% smaller. I think I have it backwards. Yeah, it's 20. It's 20% of that. Yeah, it's 20%. 10% is climbing. So I'm gonna verify. I'll put it out in WhatsApp. But I know it's 10% for climbing. That I know for sure. 20% for, it's a 5-to-1. It's 5-to-1. I'm thinking rigging stuff. Okay, 20% of when you're using in a rigging application. So 20% strand count within 6 inches of lay, 20% of glazing, 20% of wear. Okay. Okay. Any questions? All right, I'm going to dive in real quickly with nylons and Dyneema slings. Yeah, and then next week we'll go into PPE inspection and hardware. We're going to transition into hardware. Okay, so some just key things I want to point out while we do nylon stuff because I can't do a full hour on it. Okay, so with your loop runners, okay, so you're going to have Dyneema. Dyneema is going to be a higher strength or tensile strength sling. UV degradation, abrasion resistance is going to be its downfall. Okay, nylon. Okay, you're going to have a low melting point, but cheaper to make. Okay, lighter weight, stronger, cheaper to make, a little more robust, I believe, and better UV protection. Okay, on your nylons, anytime that there is any damage to the stitching, and not like the fraying, but actual complete. You with me? Okay. Make you do push-ups, you do that again. I know I'm ugly, but you got to look at me. Okay. Anytime there's any nicks within that the weaving, it's got to go. Okay. You can have light fluffiness going on, but anytime there's cuts into that, that's got to go, and that's for both. Okay. With the stitching on it, and I'm going to show you on our harnesses too. The stitching on the sling or on the webbing, if it is important, it's going to be a different color than the device itself or the strand itself. Okay, so notice how that stitching is black, but this is blue. Okay, that means that stitching is important. Anytime any of these stitching is cut or missing, it is defective. Okay, that is part of its strength right there. Okay, now the reason I mention that is for our climbing harnesses. All stitching on climb harnesses are going to be a different color than the main webbing that's on it. Okay, so this webbing here, right? It's holding my my lanyard D. Okay, that's important. That black webbing there, right? Now, if you can see, the stitching on there is different. What color is it? Gray. Okay, it's different than black, right? So that means it's important. That means I need to inspect that. So when you guys are doing your PP inspections, your harness inspections, that is important. If it's part of holding your life on, it's a different color than the webbing that's on it, that stitching is important. Now, if you'll see, what color is that stitching? Black, right? Okay, is that stitching important? No, nope, it's not. Okay, so this stitching does not matter because it's the same color as the webbing. If it's a different color, I'm gonna repeat, if it's a different color, it's important and it needs to be there. So the second that I have cut strands on that stitching, my PPE, my harness is defective and it needs to be removed. Copy? Okay, cool. Any questions on that? Industry-wide. Yes. I'm gonna say yes, because yeah. Cool. All right. Okay, any questions? All right. All right, let's circle up. Let's chairs away.